Hello, welcome to class. In today's class, we are going to be looking at electrolysis. I'm going to give you a foundational understanding on electrolysis. The word electrolysis can be divided into two subwords. First, electro, meaning electricity. The next is lysis, meaning a splitting or breaking up. You can also call that decompose. So, there is a substance that splits or breaks up or decomposes in the process of electrolysis. The electro means that what is responsible for this splitting is electricity. And when we're talking about electricity, we speak of electric current. Let's look at some of the terms used in electrolysis. The first term used in electrolysis is the very word electrolysis. So, by means of standard definition, what is electrolysis? Electrolysis is the chemical decomposition of a compound brought about by passing a direct current through this compound when the compound is in its molten form or when the compound is in its solution form. When I'm talking about solution form, I'm referring to an acquired solution of that substance or that compound. Remember that an acquired solution is a solution in which the solvent is water. Let's look at the next term, electrolyte. What is electrolyte? Electrolyte is the compound which conducts electricity and it is decomposed in the process of electrolysis. The compound which conducts electricity and it is decomposed in the process of electrolysis. That is what we mean electrolyte. Remember also, in fact, it is a point to note under the second term that for a compound to behave as an electrolyte, that compound must be in its liquid form. That liquid form can be an aqueous solution of that compound, or it can be the molten form of that compound. So, a molten form of that compound or an aqueous solution of that compound is the liquid forming, the two liquid forms in which that compound must be for it to be called an electrolyte, for it to conduct electricity. An electrolyte means that it allows electric current, it conducts electricity. Yes, allows electric current to pass through it. In addition to this, it's important to note that a non-electrolyte does not behave in this manner. Yes, doesn't behave in this manner. And electrolyte conducts electricity by the movement of ions. It is the ions present in an electrolyte that causes an electrolyte to conduct electricity. We will talk about ions much later on as we proceed in this video. Stay tuned and make sure you subscribe. Stay tuned and make sure you subscribe. The next term is electrodes. Electrodes. What are electrodes? These are conductors in form of wires, in form of rods. It can even be in form of plates, which an electric current enters or leaves the electrolyte. You can also say that electrodes are conductors in form of wires, in form of plates, and in form of rods through which electrons enters or leaves the electrolyte. So, those are electrodes. Electrodes can be divided into two. We have the anode and we have the cathode. You can see here, I am putting a positive here. The anode is a positive electrode. It is a positive electrode through which electrons leaves the electrolyte. You can see the anode here, positive electrode through which electrons leaves the electrolyte. So you can see the electrolyte. That's the and you can see this arrow is showing you that that's the direction of the motion of electrons. You can also say that an anode is a positive electrode through which conventional current enters the electrolyte. This should not be confusing to you at all. The direction of motion of electrons is opposite to the direction of motion of conventional current. So the conventional current moves in the direction which is opposite to the movement of the direction of electrons. So if the electrons is moving in this direction, if it's leaving the electrolyte through the anode, then conventional current is entering the electrolyte through the anode. The cathode. The cathode is a negative electrode. It's the electrode that is negatively charged. And this is the electrode, a negative electrode through which electrons enters the electrolyte. So you can see the direction of motion of electrons, alright? And you can see that the electrons enters the electrolyte through the cathode. Or you can also say that the cathode is a negative electrode through which conventional current leaves the electrolyte. The anode, conventional current enters while electron leaves. The cathode, conventional current leaves while electron enters. So this is the difference between the anode, which is the positive electrode, and the cathode, which is the negative electrode. So, note that. Let's look at electrolytic cell. It's another term used in electrolysis. The electrolytic cell is an assembly of two electrodes in an electrolyte and is used for the electrolysis of the substance. The assembly, alright, of two electrodes inside an electrolyte used for the electrolysis of the substance, that's what we mean by electrolytic cell. That is to say that this setup is an electrolytic cell. In the early days, the electrolytic cell was also called the voltameter, alright? But currently, it's electrolytic cell. This is what we call it. Alright? It is a cell that is responsible for electrolysis. Now, if you look at the fifth term here, the fifth term here is ions. That's the next term here. And before I talk about this, we are going to look at the ionic theory. But just before that, it's important you note something. It's important to note that in this diagram, it's as if I've not spoken about this. Okay? So this is a battery, a cell, a combination of cells to make a battery. It is the source of electricity, the source of electric current. So see the source of electric current here. This is this cell, alright? This is called an electrochemical cell. There's a big difference between electrochemical cell and electrolytic cell. In the electrochemical cell or a battery, you can see that the positive terminal is called the cathode, while the negative terminal is called the anode. That's for electrochemical cell. But in electrolytic cell like this, that two anodes are put inside electrolyte, the positive electrode is the anode and the negative electrode is the cathode. So there's a difference between electrolytic cell and electrochemical cell. So note that this should not be confusing at all. The positive, and note that the positive terminal of the battery is connected to the anode, which is the positive electrode, and the negative terminal of the battery is connected to the cathode, which is the negative electrode. Let's talk about ions. An ion is an atom that has either lost electron or gained electron. Remember, when an atom is at ground charge, or you can say that's light of 0. When an atom loses an electron, it becomes positively charged, or you can call it a positive ion. That positive ion is also called cathode ions because that's the ions that will move to the cathode. The cathode is negatively charged. Positive ions will move to the negatively charged cathode. This is to obey the law of electricity that like charges will repel and unlike charges will attract. So positive ion will go to the cathode. And cathode ions is also called cations. This is the most conventional name you're going to hear for this positive ions, cation. This is what you may see most times circulating in our videos. Cations, short form for cathode ions. If you look at this, you will discover that at the beginning of the video, I had deliberately interchanges. Alright? I have just changed it now. I just wanted you to begin to ask yourself some questions in your mind because most students mix these. Most students say that positive ions are the anode ions because the anode is positive. So positive ions become anode ions. No, that's wrong. That's wrong. Please avoid that confusion. I have corrected it now. I just did that just to because most students make that mistake. Don't make that mistake. I have corrected it. I deliberately put it so that I could show you, I could tell you that that is wrong. Another type of ion is a negative ion. The negative ion is negatively charged because it gains electrons. It contains more electrons. And the positive ion contains less electrons. Because it loses electrons. Negative ions gains electrons. Negative ions is also called anode ions. The anode ions, they are the ions that move to the anode because negatively charged move to the positively charged ions to obey the law of electricity, static electricity. The most conventional name is anions. So the cation is positively charged, the anion is negatively charged. The anode is positively charged, while the cathode is negatively charged. This can be a bit confusing, but practice and consistent running through this makes it simple and easy to understand. Let's talk about the ionic theory. The ionic theory was first presented by a man called Arrhenius in 1887 to explain electrolysis. What was the proposal from Arrhenius? This theory proposed that when an electrolyte is melted or dissolved in water, some of that electrolyte, if not all of the molecules of that substance, will dissociate. It will split, it will break up into freely moving charged particles. And this freely moving charged particles is called ions. This was a proposal by a man called Arrhenius. This theory tells us about the ions in the electrolyte. So, in this theory, we are going to look a bit closer into this electrolyte. So, according to Arrhenius, even when the electric current has not yet entered this electrolyte, Arrhenius theory holds before the electric current passes through the electrolyte. Arrhenius theory says that before the electric current even enters the electrolyte, as long as the electrolyte has been made to be in molten form, as long as the electrolyte is melted in water or dissolved in water, inside the electrolyte, I have positive positive ions, and I also have negative ions. Trying to represent it by some small circles, positive ions, and I have negative ions, negative. Okay, let me put this positive, let me put this negative, and negative. So what I am showing you here is just a sketch, alright? So the concept is that there are positive and negative ions scattered around the electrolyte. They are distributed inside the electrolyte as long as the electrolyte is in molten form. So electric current has not yet entered the electrolyte. This is Arrhenius theorem. As long as the electrolyte is in molten form. So if the electrolyte was sodium chloride, for instance, Arrhenius is telling us that sodium chloride in a solid state, if you dissolve it in water, what I will have, it contains sodium ions and it also contains chlorine ions. This is according to Arrhenius. So a modernized theory is something like this. Na plus and plus Cl minus. So for a solution of this type of electrolyte, we have positive ions, which is the sodium ions, for instance, and we also have negative ions, which is the chloride ions. This was the proposal brought about by Arrhenius. So, how then can we capture the electrolysis of a substance? Look at this closely. So, according to Arrhenius, these ions are just there in this electrolyte. When the electric source is connected, something begins to happen. What begins to happen is that the conventional current will enter the electrolyte. Through where? Through the anode. Remember that the anode is where the conventional current enters the electrolyte, or through which electrons leaves the electrolyte. When conventional current enters the electrolyte, what happens is that the ions in the electrolyte, the positive ions and the negative ions in the electrolyte, remember that the negative ions are called the anode ions. I almost made that mistake. Alright, negative ions are called the anode ions. So these negative ions will move to the anode. Negative ions will move to the anode. Negative ions will move to the anode. Negative ions will be attracted to the anode. And the positive ions will move to the cathode. Positive ions 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 to the cathode. Negative ions will find its way to the anode. So the positive ions move to the cathode. That is why the positive ions are called cathode ions. Remember, positive charge cannot move to the anode. Positive ion cannot move to the anode. Why? Because it is not obeying the law of static electricity, that like charges repel and unlike charges attract. Because the positive ion is unlike with the charge of the cathode, that is why the positive ion is going to be attracted to the cathode. And the negative ion is an unlike charge with the charge of the cathode, that is why the negative ion will be attracted to the anode. Negative ion unlike charge to the anode. That's what is going to happen. In this process, in this mechanism of electrolysis, when the negative ion gets to the cathode, what will happen is that, remember that the negative ion contains more electrons. And before that ion became an ion, it gained electron. So, it means that this negative ion has to return back to its ground state. when the negative ion is attracted to the anode, it will return back to its ground state. How will it return to its ground state? It will return to its ground state by losing electrons. Yes. Remember, for an atom to be negatively charged, it has to gain electron. For it to return back to its ground state, it has to lose an electron. That is why the negative ion will lose electron at the anode. And when the negative ion loses electron, that ion will become, it will become ground state atom. This is what we mean by saying that a substance is discharged at the electrode. So the negative ion, when it loses electron at the anode, it is called discharge. Another word being used is that it is deposited as a ground state atom. Deposited as a ground state atom. So it will lose electrons, and the electrons which it loses would flow through this part and gets to the cathode. Meanwhile, the positive ions was attracted to the cathode. Or you say the cations was attracted to the cathode. When the cations is attracted to the cathode, remember that the cations contains less electrons. So, what the cation will do is that the cation will receive, it is going to receive this electron that came from this electron that came. So, the cation gains electron. And when the cation gains electron, you will see that the number of electrons and protons will be the same. That means the cation will become discharged as a ground state atom. It will be discharged as a ground state atom. And when it discharges as a ground state atom or deposited at the cathode, alright, so that's what happens. It gets attracted to the cathode and it is deposited as a ground state atom because it has gained electron. And the anion at the cathode loses electron and become a ground state atom. Take note. As the anion loses electrons in the anode, electrons is leaving electrolyte through the anode, the process whereby electrons is leaving the anode, that loss of electron at the anode by the anion, that process is called oxidation. So you can say that oxidation takes place at the anode. Why? Why? Because oxidation is the loss of electrons. And if you go to the cathode, at the cathode, the cation gains electron. And the process whereby the cation gains electron, that process is called reduction. So you can say that reduction takes place at the cathode. So, at the anode, oxidation takes place. And at the at the cathode, reduction takes place. Reduction, gain of electrons at the cathode, oxidation, loss of electrons at the cathode, at the anode rather. This is the mechanism of electrolysis. If you understand this basic in electrolysis, you are good to go because this is the foundation. This is what happens. These are the electrolytic reactions that take place. That means that there are two major reactions that happen in electrolysis, in the electrolytic cell rather. That is the oxidation reaction and the reduction reactions. And I want you to stay tuned, I want you to subscribe, I want you to share, because in our next video, we will be looking at preferential discharge of ions in the electrolytic cell. We'll be looking at Faraday's first and second laws of electrolysis. So please stay tuned to watch my next video, because this will be an interesting journey. Remember, your journey to mastery begins here. Your journey to mastery begins here. Thank you. See you in my next class.